All right, welcome back, Physics 1 students and other randos from the internet. We've made it. This is part 4, the last part of our Excel online tutorial. So you should be on the last sheet, which is the trigonometry sheet in your Lab 0 template. So before I get into how to do the calculations in this table, I want to explain where these numbers are coming from and what our reference triangles look like, okay? Just so that we have a little bit of background before we do these calculations. All right, so I'm going to open up PowerPoint. Here we are in PowerPoint. So this is an overview of part 4, okay? So this table here should look pretty familiar. It's just I've filled in variables for everything that we're going to be calculating or values that we already have, right? So we already have D1 and D2 and theta 1 and theta 2, right? That's these values here. D1 is 1 meter, D2 is 2 meters, theta 1 is 30, theta 2 is 45, right? So these are our given values. The things that we need to calculate, that's x1, y1, x2, y2, dt, theta t, xt, and yt. Okay, so I'm going to go from top to bottom. So we're going to calculate x1 and y1 first. So the formula that we're going to use, that's right here. So x1 is b2 cosine radians c2, where b2 is this value here, and c2 is our angle. All right, so just to, as I mentioned, I wanted to give you a visual representation of what we're calculating, so I'm going to click on the next slide so that you can see this, see the actual reference triangle where these values are located. So the information that they gave us was leg 1. They told us that the distance, D1, is 1 meter, so that's for this hypotenuse right here, okay? And this is a right triangle, so this is our right angle over here. Our hypotenuse is 1 meter. Our reference angle is 30 degrees, so that means that with respect to the positive x-axis, this hypotenuse makes an angle of 30 degrees, okay? Now the values that we need to calculate, that's x1 and y1. So we're just doing simple trigonometry, as the name of the exercise would suggest. So what I've done here is I've rearranged our SOHCAHTOA equations, right? So, well, not the TOA part, just the SO and the CA part. So this is the SO part, right? So sine of theta is equal to the opposite over the hypotenuse, right? So in this case, this is our opposite side, y1, and our hypotenuse is d1, right? Sine of theta. So literally all we did here was we rearranged the SO part. So sine of theta is equal to our opposite over hypotenuse. We multiplied both sides by the hypotenuse over 1, giving us this rearranged equation, right? So we get that the opposite side is equal to the hypotenuse times sine of theta, okay? Then for the adjacent side, x1, we have cosine of theta times the hypotenuse is equal to the adjacent side. So we've rearranged the CA part of SOHCAHTOA, and that was cosine is equal to the adjacent side over the hypotenuse, right? So we just multiplied both sides by d1, right? The hypotenuse over 1. So then we're left with adjacent side is equal to the hypotenuse times cosine of theta, right? So one thing that I do want to point out, though, these equations are simplified. This is not exactly how you'll type it into Excel. Why? I will tell you why. It is the one pet peeve that I have with Excel. So in Excel, you must convert any angle in degrees to radians. Don't ask me why, but the default is not degrees. I think I speak for most people when I say that we think in degrees more than we think in radians, but whoever the programmers are who wrote Excel, they made radians the default, okay? So if you're not working with radians, which we're not going to be working with radians this semester, we are going to need to convert, all right? So that means we don't want Excel to automatically assume all angles are radians, okay? So make sure that we're using the radians command. So for example, in cell D2, we're trying to calculate x1. The simplified equation is x1 is equal to d1 cosine of theta 1, right? But in Excel, you have to type equals b2, our hypotenuse, right, d1, times cosine radians of C2, which is theta 1, right? And then close the parentheses. The reason we have to do this is because the radians command tells Excel to convert this angle in degrees to radians before computing the cosine and multiplying by B2. If we didn't put in radians, it would automatically assume that C2 is in radians, okay? And that is not the case, it's in degrees, so then we would get a really horrible answer, right? That would make absolutely no sense. All right, so let's head back on over into Excel and let's perform those first couple calculations. So we have equals, right? We're letting Excel know that we're doing math. We want our hypotenuse times cosine, open parenthesis, radians, right? Because we have to convert our angle that's in degrees to radians. Then we're going to close the parentheses and hit enter. Now you'll notice that I've got a runaway decimal place. At the end, we're going to clean up the decimals so that everything has 3 decimal places, just like these here. Now, I realize that in the prompt, they did not give you 1.000. It was just 1 by itself. But there will be times where we are going to not necessarily follow the rules of significant figures, because the prompt indicates that we didn't have any decimal places at all on our measuring device. So technically, we shouldn't be departing from the significant figure standard. But there will be times where in lab I'm going to ask you to include more significant figures than you should, right? Remember when we talked about with the data entry and the graphing and stuff, you know, we don't want to have more decimal places, right, than just the 1 decimal place, because that we don't want to exceed the precision of our measuring device. All right, but there will be times, and I will always let you know what times those are and how many decimal places I want so that I can follow your math, but there will be times that we're going to depart from the usual rules of significant figures. All right, so let's get back to the trigonometry part. So now I'm going to do the opposite side, right, our y1. So we have equals our hypotenuse times sine, open parentheses, radians. There's our angle. We're going to close the parentheses, hit enter. There we go. Now, if you'll notice, if we go back into PowerPoint, if you'll notice right here for x2 and y2, we have pretty much the same equation. You know, we're just doing it for this row now. So that means we don't need to type those equations in again. We can just drag and drop. So that's what I'm going to do. Drag and drop. All right, so now we're done with the first 2 rows. Now we can focus on the last row. So before we start doing the math for the last row, I do want to go back into Excel and show you visually what that's going to look like. So the first things that I'm going to calculate for the last row are going to be xt and yt. Why? Because they're really easy. And also because we need them for the other things that we're doing, right? This has xt and yt in it, and this has xt and yt in it. So if we don't have those yet, we can't do those calculations. All right, so we have to do xt and yt first. These are simple summations, right? We're adding x1 and x2 to get xt, or x total, and then we're adding y1 and y2 to get y total. Okay, so let's go back into Excel and we'll do that. So there are 2 ways that we could do this. The way that I'm going to do it is I'm going to simply add them, but if we had more than 2 legs, if we had like 8 legs or something, we would probably want to sum them. Okay, so I'll show you both ways. So equals, we're telling Excel we want to do math. We're going to add x1 to x2. All right, and there we go. And then we're going to be doing the same thing for y, right? So you'll notice up here, right, now we have E2 and E3 added together. That gives us y total. Now the other way that you could do this, like I was saying, if we had multiple legs, it would make way more sense to do it this way, is you can use the sum command, okay? So you hit equals, you type in the word sum, you open the parenthesis, and then you highlight all the values that you want to sum up. All right, that's just the 2 values there. All right, we get the same answer. I'm going to pull this over here. So now we have y total. So now we have x total and we have y total. So now we can find our distance and angle, you know, for the total row. Okay. The first one that I'm going to do is I'm going to do the dt, right? So let's take a look back at the formula. So that's going to be the square root of this squared plus this squared. Why? Let's take a look at the reference triangle. Okay, so here's our reference triangle. DT is our hypotenuse, XT is our adjacent side, YT is our opposite side. Okay, so how did we get this equation? Pythagorean's theorem, right? This is a right triangle, right here is a right angle. So if we already know XT and YT, essentially that means we know A squared and B squared, then we can find C squared, which is our hypotenuse, right? When we do Pythagorean's theorem, A squared plus B squared equals C squared, where A squared and B squared are your adjacent and opposite sides, and C squared is your hypotenuse, right? So you can see right here, we have, let's just pretend A squared and B squared, right? Our adjacent side squared plus our opposite side squared, and then we're taking the square root to find the hypotenuse, right? So let's go into Excel and calculate that. So we do equals, let Excel, we're doing math. Then we type in square root, which is SQRT. We're going to open the parentheses. We want to square this value. And then we're going to add it to this value squared. All right, there we go. Now we have dt, right? And the last thing that we need to do is we need to find theta t. All right, so let's take a look at our visual again. So theta t is equal to inverse tangent of yt over xt, right? Yt over xt. So that's the last part of SOHCAHTOA, right? The TOA part. So tangent is equal to our opposite side over our adjacent side. So this might be a little bit counterintuitive in Excel. So when we want to find the angle of a right triangle, of course, remember that Excel likes to work in radians. So we're going to have to enter in degrees, and then for arctangent, it's going to be atan2 is the function that we're using, okay? So please note that in Excel, when we want to find an angle of a right triangle for which we know the adjacent side and the opposite side, xt and yt, and we want the angle in degrees using inverse tangent, we use this equation, right? Equals degrees atan2 xt comma yt. I realize that this bit is a little bit counterintuitive because when you look at the equation, it looks like y should be first, but Excel automatically prompts you to put in your x number, then your y number. So, I mean, that at least makes it a little bit more straightforward. All right, so let's do that last calculation. So we want to do equals, degrees, open parenthesis, atan2. So we want this one. And you can see right here, it prompts me to put my x number in first, then a comma, then my y number. All right, unfortunately, I'm already into this cell here, so I'm just going to have to type D4. So D4, comma, E4, all right, and then close my parentheses, hit enter, and there we go. We've got the last one. So as promised, I'm going to show you how to decrease the number of decimal places, right? Because we want to have all of them with 3 decimal places. So I'm going to go up here to where it says decrease decimal. I'm going to hit that one time. Then I'm going to increase my decimal so that I get back up to 3. Okay? So there you have it. We've got the whole trigonometry section done. And this concludes part 4. I hope that you found these online tutorials helpful. And if you have any further questions, feel free to ask me in class.